Hi, this is David Hammett. Today I'm going to be doing my review of the public lecture for Physics 2212. The lecture I went to was a third public lecture, and it was from the Smarter Everyday guy. Let me see if I can remember what his name is. Yes, Destin Sandlin. So his name is Destin Sandlin. He's from Smarter Everyday, and he was talking to us about how to view science differently. So some of the things we talked about were how helicopters are able to fly, how cats who are falling are able to land on their feet always. And so how we viewed science differently is sort of taking a view that you don't have to necessarily know all the specifics of this equation and that equation and all these theorems to understand just how science works just by using basic principles and theorems, and also how you can apply science to your everyday life in order to do things more efficiently and in order to learn some things. So for this video, I wanted to delve specifically into that last bit that I talked about, which is how cats are able to fall and land on their feet. So the observation is we're able to drop a cat holding it by its feet and holding it by its feet to where it's upside down. And you can drop the cat usually from about at least a foot, and it will land on its feet. Assuming you don't drop it from too great a height, it will land safely because it lands on its feet, among other things. And I'll get into that. So it's a really curious observation. It took people a long time to figure out how this works. And as you can imagine, scientists and just casual observers who really are scientists had observed this for quite some time. So how this works is take this cat, which I have drawn right here. It's a different color. So take this cat that's falling, and so he's moving this way, and this cat, so the first thing that happens when a cat is falling, and it's upside down, is it uses its vestibular membrane, which is located in its inner ear, or, if it's daytime and there's other visual cues, it can also tell visually. Those are the two ways that it can tell that, hey, I'm falling and I'm upside down. And so when that happens, they will begin what is called the vestibular righting reflex. So cats have a special reflex called the righting reflex, where they right themselves while they're falling. So this video is going to explain how that works. So first, our poor cat is in a predicament, and he's falling, as I just said, and he wants to get to where he can land on his feet. Because if he can land on his feet, he can more evenly distribute the impact throughout his body, distribute the force throughout all four of his feet, and he'll just land more safely. So the first way that they do this is that, so when they're falling, so I'm going to draw in, let's see, I can draw in orange here an axis. So pretend this is a straight line. But this axis goes through the middle of the calf body, and that's the axis of his, quote, rotation. He's not rotating yet, he's just falling. We're assuming that he hasn't been giving in any initial angular momentum. But that's his single axis. So in order for him to turn, what he does is he or she does is first they will bend their body towards the middle, so that their upper body, which is the part with the head, obviously, can rotate in a second around a different axis than the lower part of their body, the lower part, upper part. So so that's the first step, is that they bend towards the middle. And just to be clear, I will draw in, let's see, purple, the motion of the cat. So the cat has bent its front end inward and its back end inward, so it's really just moving in on itself. Sort of like being over and touching your toes, only you're falling. So the second step, and so as you can see, they've not changed their total angular momentum because they aren't even, while the cat's front end is rotating this way and the cat's back end is rotating this way, if you add those up, they cancel out. So, yes. So the second step is, let me again draw these axes. So I'm sorry for the my not so great drawing. This was my best attempt at drawing a cat. I happen to be allergic to cats, so I don't know if I've ever seen a cat before. I'm just joking. But so yes. So the second step is that the cat now has bent towards the middle, and he wants to start rotating to where he'll land on his feet. So the first thing we do is, I'm not sure if you can see it too clearly, but the cat will bend its front legs inward. So let me draw a little better. So his front legs were here, now they're going to be here, bent in as close as you can have them, and the back legs, he will bend them outwards. So what's the reason for this? Well, the reason is that now, while he's falling, he's able to, while he's turning, his front legs bend inward, so that the total angular momentum of the front half of his body is less. I'm going to represent angular momentum with L. So here he has angular momentum L, and then now, let's see. So if this is big L, he will now have angular momentum 1/2 L here, and 1/2 L here. Assuming equal mass distribution, I suppose. So now, by bending his front legs inward and extending his his behind legs backwards, he is able to make this L quite larger than this L. And while they will still add up to produce this original angular momentum, they are different on these two axes. So the reason he's doing that is because if you might recall from Physics 1 that if you decrease your angular momentum, if you decrease your moment of inertia, so my bad, replace all of these obviously with moment of inertia. Actually don't. Let me go back just a second. So you have decreased your moment of inertia here, So you can learn from my mistakes. So you can't actually change your angular momentum on either side. But what you can do is if you change your moment of inertia by decreasing the radius by moving your front legs outwards, you increase the moment of inertia by extending your hind legs outwards, you create a differential moment of inertia. What that means is that angular momentum is governed by moment of inertia and omega, which is your rotational speed or velocity. So by decreasing this I, in order to keep the same 1/2 L on each side, the cat's front side will have to rotate at a larger speed. And since this side has increased its moment of inertia, it will rotate at a smaller speed, omega. And again, the size of these letters is representing the size of those, or the magnitude of those quantities. So now, as you can see in this next step, I have drawn the cat's face facing forward while the hind legs are still up. That is because the front end, as we've just said, has been rotating faster towards us than the back end. Now that he's already moving this way, what the cat will then do is extend its front legs back outward and retract the hind legs, so that let me just say cover. So the cat will extend his front legs back out and retract the hind legs. So that does the same thing. So we want to have the same angular momentum 1/2 L along each side. But this time we extend our front legs, so our moment of inertia is greater and our angular velocity or our angular speed or angular velocity is smaller, while on this side we have decreased the velocity, we have decreased the radius, which decreases the angular, one more time. On the hind side, we have decreased the moment of inertia, which allows our angular velocity to increase, so many angulars. And once again, these will have the same L's that they've had this whole time. And last but not least, the cat has now, the front end finishes rotating at a slower speed, and the back end catches up to the front end because at this point it was rotating slowly. And this side, and this side was rotating more quickly. And then on this part, the back end was rotating more quickly, and the front end was rotating more slowly. And so in the end, it evened out, and the cat was able to fully rotate to where it would be able to land on its feet, which is great for the cat because that's what he's trying to do. And the reason, the evolutionary reason for the cat developing this reflex is so that the force can be even more evenly distributed throughout its body and help it land more safely with less damage to the cat's body, because it is able to more evenly distribute the force throughout its feet and into and throughout its body, which is great because that's less differential impact on different parts of the body, less damage to different parts of the cat's body, and overall a cat that is less hurt from the fall, which is ideal. So that is the several part process of how a cat falls. Once again, it's falling, it bends its body inward towards the middle, then retracts front legs, extends hind legs so that he can rotate more quickly in the front, then does the reverse so he can rotate more quickly in the back, lands on his feet safely. So hopefully you found that useful. And the last topic that I wanted to discuss is that of cats falling in zero gravity. Whoops, that's not a cat. So I'll go with that. So if you have this oddly round cat, it's supposed to be a regular cat, and of course it's smiling, but it won't be for long because, so imagine that you have this cat which is falling, as we've had the other cat doing, but this cat happens to be falling in an elevator. So imagine you have a cat, and you go into an elevator, and then someone cuts the cord in the elevator, and you and the cat begin falling. And so before the cable was cut, you were holding the cat upside down by its legs, as before. And then once the cable was cut, you both begin falling, and then you release the cat. What's different about this situation is that in this situation, you and the cat, one, are probably going to get very much hurt at the end, but number two, any time that you're falling, you and the cat are actually in zero gravity because no net gravitational force is actually acting upon you because you are in free fall. What's different about this for the cat is, as I said before, the first part of the righting reflex is for the cat to tell which way is up and which way is down so that it can right itself. And I said that there were two ways for it to do this. One was visually. So the issue with this situation would be that you're in an elevator, and so the cat probably truly has no clue which side is up and which side is down. And the second, visually, and the second way, the more innate way, perhaps if cats would normally use this at nighttime maybe, or in strange situations, is through some things that humans use to balance ourselves as well, but not with falling, I suppose, is what I mentioned earlier called the vestibular membrane, which is located in the inner ear. And the way the vestibular membrane works is that it contains an amount of fluid, and this fluid is acted upon by gravity, and that region of the ear is extremely sensitive, and it allows you to sense the pressure on that, or the force on that fluid due to gravity, and the pressure on it, and therefore tell you which way is up, among other things, which way is up and which way is down. But as I just mentioned, that relies on gravity acting upon the fluid. And so when you're in free fall, there's no net gravitational force acting upon that fluid in the inner ear. So again, the cat will literally have no clue which way is up and which way is down because it's basically, it might as well be in space. It actually is not feeling any net force. And so you can look up some quite hilarious videos of actual experiments that have been done with dropping cats in zero gravity. There were some experiments done, I believe, in the 50s at least. Maybe the first ones done then by some military scientists, I believe. And they dropped cats in zero gravity, and the cats are just flailing about wildly trying desperately to figure out which way is up, which way is down, so that they can do their whole righting reflex thing. You can imagine that probably be pretty stressful because you'd have literally no clue what's happening. But and you can also see videos of other animals doing this. So it's quite interesting. And not all animals have this righting reflex, but you can see how other animals react to zero gravity, such as fish, they're pretty much good. They might as well be in the water, which is pretty cool to watch. And I believe frogs actually are able to turn to land on their feet in zero gravity, which is quite interesting that they can do that and cats cannot. Or at least they don't know which way is up and which way is down. So, yeah, so as I mentioned, very interesting phenomenon, and I do encourage you to research this more yourself. And I hope this video helped you to understand how your cat is able to land on his feet, or how cats are able to do this, given sufficient distance to fall. I want to stress that I don't encourage you to do this to cats, because that's just pretty mean. But yeah, so I hope you found this entertaining and interesting, and if you're interested, I encourage you to do research on the topic. And yes, so thank you very much for watching. I hope that was useful, and have a great day.